Okay, so today what we're gonna do, y'all had a bunch of homework to submit over the last like 4 weeks. And, if you're doing perfect on the homework, you don't get any feedback. If you've missed some, I sometimes write in the comments like what you missed them for. But I thought we could take the whole day, almost the whole day today, and go over some solutions. So that you'll have a better idea of what I expect from you and what is like great and what is like average. Is that cool? So one thing when I took high school English, the English teacher, anytime we turned in an essay, after we turned in the essay, he would always be like, this was the best sentence. And he would show the whole class who had written the best sentence. And then he would explain like why it was the best sentence. And so if yours was the best sentence, you're like, yay. And you also kind of got to see examples of other people's writing. And then you would also point out one not so great sentence, not for the purpose of like embarrassing anyone, but to use it as like a teaching example. So I'm going to show some awesome homework submissions and some less than awesome homework submissions. So that you know what I'm looking for. It's not to like embarrass anyone. There are no names attached. So you might recognize your handwriting. But mostly I just want you to be able to see what I see. Cool? Okay, I just have a couple of cursory slides before I start. Okay, so scientific notation. If it asks for it, if the question asks for scientific notation, then you should definitely put your answer. If it doesn't ask for scientific notation, you can if you want to. I just want to emphasize that here are 3 different answers that look like they're in scientific notation, but only the first one actually is. And so this is the rule that you follow. So N is the number, the very first number. That's N is like a placeholder. This number has to be between 1 and 10. So 8.4 is the correct number. 84 is too big and 0.84 is too small. So even though all 3 look like they're in scientific notation, the top one is the only correct one. So does that make sense? I didn't make those rules. Somebody made them up, but that's proper scientific notation. Okay. I didn't like deduct points. I thought about it really hard to deduct points. But I haven't been because, again, I'm like not sure. I like to count off if like you weren't sure of the rules. But now you are sure of the rules. Okay. So okay. Oh, somebody's homework taught, I don't know who taught y'all this acronym. Somebody, yeah, you taught them this acronym? Oh my God, it's so cute. Okay, so thank you for whoever shared it in your quiz as the one thing that you learned last week. This is now the one thing I learned this week. A little acronym or a sentence you can use to help you remember the order of scientific prefixes is King Henry doesn't usually drink chocolate milk. So the K for kilo, the H for hecto, D for deca, the other D for deci, C for centi, M for milli. So one thing that tripped y'all up in the homework, I want to say like at least like 5 of you got it wrong. I don't remember which question it was, but there was one question that asked you to convert grams to DG. And so because it's one single lowercase d, we know it means deci. If it had said DAG, it'd be deca.
Hey, Deb.
And then 2 other ones that came up in your homework were this hectometer. So there are 100 hectometers in 1 meter. And there are 10 to the negative 9 nanometers and 10 to the 9 nanometers and 1 nanometer and 10 to the negative 9 meters. So if you convert meters to hectometers, is your answer going to get smaller or bigger? Okay. So there are 100 meters and a hectometer. 100 meters and
So if I convert 100 meters to hectometers, is this number bigger or smaller than the original? Smaller. Okay, so this is like a trick. It's like a mind trick. If you convert to something up here, your number is going to get smaller. If you convert to something down here, your number is going to get bigger. So if there are 10 to the 7 nanometers in 1 meter, if I convert 10 to the negative 7 nanometers to meters, is that number bigger or smaller? Smaller. Yeah. So if you're moving up, the number gets smaller. If you move down, the number gets bigger. So again, this is one, I have a note at the end. You can like Google this. So if you're ever, if it ever asks you to convert your answer from meters to hectometers, if your answer is like 450 meters, you convert it to hectometers, Google it. Type in Google, what is 450 meters to nanometers? And it will tell you if your answer is right or not. Okay? So you can like check your work. And then one thing I want to point out, one thing that makes grading homework sometimes tricky is there are lots of ways to get to the same answer. And so both of these things are equivalent. So you can say there are 10 to the 7 nanometers in 1 centimeter, or you can say there's 1 nanometer in 10 to the negative 7 centimeters. Do you see how both of those are equivalent? Awesome. So I usually, to me, negative exponents are a little hard to work with. So I personally usually try to stick to where they're all positive, but these are both acceptable. They are both proper and correct ways to write equivalent conversions. Same thing here. 10 decimeters in 1 meter or 1 decimeter in 0.01 meters. Okay, so this was just the one question that a handful of people got wrong because they were thinking decameters, not decimeters. And does anybody know the definition of what 1 milliliter is? 1 centimeter cubed. So these two are equivalent. They are interchangeable. To convert from milliliters to centimeters, you don't have to do any math. You simply swap out the milliliters for centimeters cubed. That is its definition. Any questions so far? I think we're about to get to what I call the more fun stuff. Oh, okay. So then this is the one other, this is my sort of like, not really a pet peeve, but like, if your answer doesn't have units, it is incorrect. If the question is right there that says report the unit and report in grams, it's kind of obvious. I can infer what you mean. But if you were to just hand someone a sheet of paper with no question, and then there's no units, then you really don't know what's going on. So reporting a measurement, a number tells us how many or how much, and the unit tells us the scale. So both the number and the unit must be included to express a quantity properly. Okay, so what is the density of pure water? Which of these answers are correct? Yes.
5.
5 is correct. Are there any other correct answers?
6.
6 is also correct. So why is number 1 wrong? There's no units. Why is number 3 wrong?
No, it's not a density.
It's not density, it's length. Okay. So so these two are equivalent. 1 gram per centimeter cubed is the same as 1,000 kilograms per meters cubed. We could do the math to show that. But it has the unit, sorry, it has the number and the unit. And so this is one reason. So these two things mean the same thing. 1 gram per centimeter cubed and 1,000 kilograms per meter squared are the same thing, but 1 and 1,000 are not the same thing. That's why if you just say 1, I don't know what you're talking about. If you say 1 grams per centimeter cubed, I know exactly what you're talking about. Okay, yes. Okay, so I don't know if you have your homework, if you want to pull it out while I go over some of these, you're welcome to. Otherwise, you can listen and take some notes. But I picked a couple examples from a handful of homeworks and labs. So we'll start with homework 1 conversions. Okay, this was a great answer. So it's not showing the work, but the work's on the next page. So what do I think is awesome about this homework, Karen? What do you think? It's neat. It has units. Yes, thank you. Okay. And also there's one more. There's one more. The box makes it really clear. What is it? It's in, one of them is in scientific notation. There's close. We're so close. Significant. Sig figs. Yeah. So the number of digits in his answer matches the number of digits in the previous one for the most part. Okay. And then this gets even better because now the work is shown on a different page. So what looks really good about this homework here? It's neat. Yeah, I can read it. What else? Yes, it shows step by step. I know exactly where all the numbers are coming from. All the units are crossed out so you can see how they got to the units at the end. But this is a really great example. Awesome. And then once again, this is where it really makes sense. Like the answers have a box around them. So this makes my life grading easy. Like, sweet, right answer, right answer, right answer. Next page. Okay. So did anybody have any questions about any of these conversions? It's been a long time. Okay. Okay, so then lab 1 was a math review. I don't know if you want to pull that sheet out or not. Okay. This was a beautiful example. Does anybody know why this was such a great answer? 2 of these. There's 2 answers, 2 questions. I guess it's like repetitive at this point. Really neat handwriting. I put the boxes around it. So who said step by step earlier? Yes, okay. So what's great about this one is I can see step by step what is going through this person's mind as they do the equation. So they're trying, first thing they do is they move the 32y over on this side. You get 56 minus 32, and then they divide both sides by -9. And then this gives us this answer here. Beautiful. It's very easy to follow. It's all in line. Same thing for this next one. They've cut out a lot of steps, but it's written so neatly, I can follow along. So for this one, they're trying to solve for x. So they move the y plus 4 over to the 17. Then they divide by 1.5. Then they add 5 to both sides. So this is really easy to follow their work. I know that they understand the concept. I can read everything clearly. Awesome. Anybody have a question about how to solve these 2 problems here? Awesome. Okay, so how would we solve this problem here? So PV equals nRT. PV divided by NT equals R. Beautiful. You can also, if it looks a little backwards, you can also move things across. So PV equals NTR, nRT is equal to, you can kind of move it across. R equals PV over NT. So you can move equations around, remembering to divide. So some people, you can show your work even more, like you can say, this is divided by NT, and this is divided by NT, if that works for you. And then cross out the N and the T and the N. Sorry, it doesn't cross out on that side. So the more work you show, the better, because I can tell that you're understanding the concept and not just grabbing an answer from your neighbor and putting it on the page. Okay, homework 2, any questions about simple conversions and solving equations? Okay, we'll go to homework 2. Okay, so this question, a lot of people got halfway there. So if the speed of sound is 343 millimeters per second, how many seconds does it take the sound to travel 1 mile? So I like this. I like the way this person solved this problem. They started with their answer. So we start with 1 mile. And then we convert, because we're trying to get to meters. So we go kilometers, 1.609 kilometers per mile. We get meters, 10 to the third meters per kilometer. And that equals 1,609 meters. And then they divided that by 343 meters per second and got 4.69 or 5 seconds as the answer. Does anybody have any questions about how that logic works? So one place that a lot of people had trouble was that they converted this meters per second to miles per second and then stopped there. But the answer wants us to know, so that's just your speed. If you convert that to miles per second, you're still at the speed and not a distance. So then you have to multiply that by 1 mile to get to your distance. See if I have, oh, anybody questions about that one? I think that confused a few people. Okay, lab 2, cruising right along. Okay, this is why I probably should have done this right after that one slide. So here, this is asking you to go from centimeters to hectometers. Okay, so centimeters are kind of in the middle and hectares are way up here. So if we have 11 centimeters and we convert that to hectometers, do we expect that number to be bigger or smaller than the starting number?
Smaller.
Smaller. Okay, so a lot of people had a bigger number here and that's not possible. Same thing here. There are, this one, oh no, oh. Okay, this one's wrong. Okay, so this one's actually wrong. Oh, so a lot of people.
Converting to nanometers, not centimeters.
Yeah, so this one's converting to nanometers to centimeters, but
That is correct.
no. Okay,
It's wrong. But
it's looking pretty good. It looks good. This is why some people can fool me. If you have nice handwriting, sometimes you can fool me. But let's go back. Okay. So how many nanometers are in a meter? 10 to the 9. How many centimeters are in a meter? 10 to the 2. What's the difference between 9 and 2?
7.
7. So some of you got this right. So this conversion here should be 10 to the 7 nanometers per 1 centimeter. Okay, I'll fix this on this one here. So this one is close. But this is not, this is 10 to the 3. It should be 10 to the 3. It should be 10 to the 7. So I must have just been looking for like positives. A number that was larger, but this one is off. This should be a 10 to the 7. Okay, any questions about how to convert? Okay, I've mostly been showing really good answers for a while. I'll get to some ones that have mistakes. So this was from a lab 2, the density of aluminum. So the question was, what's the mass, given the mass and volume of your aluminum pellets, calculate the density. Okay, so what does this person start with? The formula or the equation. That is like the best thing you can do to help me grade your paper is to write the formula that you're starting with, and it will help you get the right answer. So we start with the formula, then plug in the numbers, then solve, and he's showing, what do we have here? Two things are awesome about this answer.
Sig figs and units.
Sig figs and units, thank you. I'm hoping that the repetition today is what's gonna stand in your mind the most. Okay, so here is the same problem. What are some things that are not awesome about this response? There's no work shown. What is a gram a unit? Yes, it's the wrong unit. So a gram is a measure of what?
Yeah.
Mass. Density is in grams per centimeter cubed. Okay, so awesome. I'm not sure if 10.72 divided by 3 is actually 3.6, but some of yours I like check the math. But yeah, so this one, it doesn't have any work shown. There's no formula at the beginning, and it has the wrong units at the end. Okay, yeah, incorrect units, no equation, and incorrect significant figures. If these were the right significant figures, we should just have one significant figure, 4 grams. Okay. I'll show you just a couple more. Oh, this is one more different problem on the end of your lab 2, calculating the thickness of foil. This was kind of a hard equation for a lot of people. So there's 2 things going on here. Okay. So you're supposed to, there's a couple things I love about this answer. First of all, they circled height. Height is what you're trying to solve for. So it's like, okay, cool. I know that we're trying to solve for height. Awesome. They write down their first equation, density equals mass divided by volume. And they write, because we know volume is equal to length times width times height, we can replace this V with this equation, length times width times height. And now they're going to plug in their answers and solve for H. And we've got the right number of significant figures, and we have our units, centimeters. Does everyone see why this is an amazing answer? Okay, and so this one isn't really like a this is an example of a 2 equation problem. So you've got density equals mass times volume, which is equal to mass times length times width times height. So this is showing you're taking 2 different equations, merging them together to get one answer. Any questions? This one, again, another way to solve this. I can see they're thinking about the equations, what to plug in. They plug in the answer, and it's very clear and understandable. So great job. So this answer here. So what are some issues with this answer here? There's no structure. Yeah, well, I might have cut it off. But yeah, I'm pretty sure there were no units. I can give you the answers. Okay, so no clear equation. The order in which we're doing this is a little unclear. No units, and it's like, is this the answer? Is this the answer? Is this the answer? Sometimes, this is why I like the box around it. Like sometimes it's kind of hard to follow your answers, so. Okay, this is why I like multiple choice quizzes. So we're gonna have a quiz at the end of the day, which is greater for me, because it's just the answer and not the showing your work. Same thing. Okay. Any questions about writing out formulas and like what I like and what helps to be great? No questions? Is that more clear on what you might expect from me when I'm grading? Awesome. Okay, so this was probably the hardest question on lab 3. So I did upload these slides to Canvas. So if you want to look at this later, if you want to go back and look at some of these, it is on Canvas, so you can check it out. So this one is asking you to find how two lines intersect. So if we're given two equations and you want to know where they intersect, how would you write that out on your paper to start with? So if they intersect, if they intersect at some point on a graph, and this is your X and this is your Y, what can you say about the Y of both equations? They're the same, they're equal. So what you can do is you can replace your Y. The mx plus b of 1 equals m1 and 2. So you can set these two equations equal to each other. Okay, so what we've done here, we've got this one here, we've got the first equation is equal to the second equation. Move things, get the x's on the same side, get the intercepts on the same side, divide, and we've solved for the very first x. So now that we know that x equals, so we'll move m1x minus m2x equals b2 minus b1, and we can solve for x. And now we can go back, once we have one x, we can go back to the first equation or the second equation and solve for y. So it's a two-step process. Got two equations, we know where they intersect. Once we solve for one variable, then we can solve for the other variable. Does that multi-step process make sense? Awesome. And so there are no units here, but yeah, so we've got the equations lined up, they show their work, x is equal to and y is equal to, two answers. Okay, this was probably, okay, now we're into like the harder part. Any questions so far? So energy, specific heat, and phase change. Okay, so sometimes like the answer's on the first page and then the work is on the next page. So question 5 from homework 3 is asking about a sample of copper is heated in boiling water to a temperature. Then it's dropped into a beaker of water at 26 degrees Celsius. Assuming the water gains all the heat lost by the copper, what's the final temperature of the H2O and the C2? Specific heat of the water is CP 4.184. The heat of copper is C 0.386. So this is the correct answer. 22.2 is the temperature of both of them. Does anybody know how you would solve this equation? Solve this question. What's an equation that we know from our conversion sheet that has temperature and specific heat in it? And mass? Awesome. Okay, but we don't have just one equation, we have two equations. We have one for water and one for copper. Okay, and this delta T can be written as temperature final minus temperature initial. So we know that they both have to have the same initial temperature, sorry, the same final temperature. So you're going to solve for TF. So how could you rewrite this equation so that you have TF? We'll have Q. What's Q divided by? What does C stand for? That's delta T is specific heat. this is our specific heat here. And you can set, because the final temperature is the same for both of them. If this is for our water over here, then we can have the same thing for our copper over here. Where Ti means T initial. Okay, so the way they worked out, it's one, I love this one. It's like they've written down all the things that go into the equation. Then solve for the equation. And they're solving for X, or temperature final equals 22.2. So with these really long equations, it helps to write down the important pieces of information. So there's this really long sentence, write down the important pieces of information, plug them into your equations. This equal sign, I can tell that they have, this is the water over here. This is copper. They solve and get X. Does everybody understand why you have two equations and you set them equal to each other? Got it. Okay. This is another one. It's a little faint, also beautiful. All the inputs are given very clearly to the top. The equations are written out. You can tell the final answer has the right units. Okay. Any questions about how to calculate specific heat or how to get temperature given specific heat? Specific heat is a constant, so you can always look it up. So if it's not given to you in the problem, it might be looked up. Okay. So this was a quiz question. How much energy in kilojoules is released when 2 pounds of iron metal is cooled from 450 degrees room temperature to room temperature 20 degrees Celsius? Specific heat is 0.44. So this was a question. A lot of people got this right on the quiz. It was multiple choice, so it's very easy to grade because I didn't have to grade it. Canvas graded it for me. But there were 2 reasons people missed this equation. And they were answers that I put in there on purpose. So if you forgot to convert pounds to grams, you got the wrong answer. If you forgot to convert joules to kilojoules, you got the wrong answer. So this is why if you write it out, be sure to write out all your units so that when you're canceling out units, you'll notice like, oh, labs and grams don't cancel out. Grams and grams cancel out. Okay. Now the thing, so homework 4, we're almost to the end. Homework 4 was called the atomic structure, but then there was this one sneaky specific heat question that got snuck in there. It's very similar to this one right here. So it's like, this is why I want to go over that one. So it's like, if we keep if these questions keep showing up over and over and over again, and you got the first one wrong, you're probably getting the second one, and you're probably getting the third wrong. So if the sample of silicone weighs 24.551 grams, it's heated at 88.5 degrees Celsius, added to 75.05 grams of water. Final temperature of both the silicone and water is 23.5. What's the specific heat? So in this one, we were given the specific heat and asked to solve for temperature final. This one we're given temperature final and asked to solve for specific heat. And again, these are known. The specific heat is known. So you can work this problem out and then Google your answer at the end to make sure you got it right. So this is how I worked out this equation on my own. Again, like specifying every single input. We do our first equation, solve for the energy of water that was absorbed. Now that we know the energy, their energy is equivalent because silicone is going to transfer its energy to carbon. So once we have that energy, we can solve for the specific heat. So a couple people did a great job here. This is one answer. And all the inputs are written out. First equation is solved for, second equation is solved for. Answer with the units. A couple more really great answers. So does everybody see a pattern here? Write down the important parts. This is how you show your work. You write down the key inputs, write down the equation, plug in your values into the equation. If it's a 2-part, solve for the first equation, then the second. Okay, what's so not great about these two answers here? If we're solving for specific heat, the answer is asked to solve for specific heat. What's wrong here? Yes, we solved for Q. They did half the problem and didn't quite get to the other half. Anything else? So if we were supposed to solve in Q, what are the units of Q?
Rule.
Yeah. So there's no units there. But either way, we're not solving for Q. So no equation, solve for Q instead of C, missing units. So these are things I want you to remember to include when you're solving your equations. So I got like halfway there, but there's still a little more to solve. But again, this is your input for your second equation. Okay. Okay, finally, okay, that's it. And any questions about specific heat? Yay, okay, right answer. Okay. So now we'll actually get into like a little bit of periodic table stuff. So calculate the number of subatomic particles in the following samples. So let's look at part B. This is a great part B. If there are 1.00 times 10 to the 15 krypton atoms, how many protons? So where did this 36 protons come from? It's the atomic number of krypton. So for this one, whatever you were given what the element was, you can always look up its atomic number. And the atomic number is always equal to what? The number of protons. Awesome. For neutrons, how many neutrons are in 3.2 times 10 to the 21 carbon 14 atoms? So what does what does the 14 mean in this equation? Carbon 14, what does the 14 mean? The atomic weight. So the weight, what is the weight equal to? Protons plus neutrons. So if the weight is 14, how many protons does carbon have?
6.
So that means the number of neutrons equals
8.
8. Awesome. So it's a little hidden equation that you have in there. So now we're going to take 8 neutrons times 3.2 times 10 to the 21 and get 25.6. This should probably, again, to be in real scientific notation, we want to move that decimal over 1. It's 2.56. This is really great work. They've showed the inputs, the output has a unit, and the work is really clearly shown. Okay. So this one took me like a long time to look at. And to me, it looks like there isn't actually any math in it. Or maybe like I can't kind of tell, can't really tell what's going on here. There's no units. I think I wrote it down. Okay, I don't know where the inputs came from. Incorrect answers, no equations, no units. When equations are written out, if you get the wrong answer, I can kind of tell like you just did some, like you've made a typo in your calculation. But when there's no work done being shown, like, dude, I don't know where you got these numbers from. Like, I'm confused here. Okay. This is a pretty good table. There is a table in your textbook that almost exactly has this. So the mass of protons and neutrons is roughly 1, which is why this works out. So when we're calculating the weight, the atomic weight of our atoms, the reason why we always say 6 protons plus neutrons is because they all have a mass of 1. And we don't count electrons because they're 1,000, like 10, they're 10 to the negative 4 times smaller. Like electrons contribute absolutely nothing to the weight of an element. We're going to talk more on Monday, we're going to get into ions. Electrons have a -1 charge. Protons have a +1 charge. If the number of protons and electrons is the same, what's the charge? 0, because they cancel each other out. Awesome. Neutrons are not charged. That's why they're called neutrons, neutral neutrons. Protons and neutrons in the nucleus. Electrons are outside the nucleus in a thing we call the electron cloud. If you add or subtract electrons, it changes the charge. We'll go on to this is what this right here is the subject of all of next week. So if that's confusing, that's okay. We haven't really gone over it. We're going to go over it more next week. If you add protons, what happens if you add a proton?
Different element.
You go to a different element. You kind of move across the periodic table. What happens if you add more neutrons?
Higher mass.
You increase the mass. And you make an isotope. Cool. Does everybody understand? That table is like a fundamental table that we're going to keep working with and building on for the next couple weeks. Does that make sense? Okay, so this was, we probably did this one a little too soon. This is a pretty good example. I can upload, this one it's not perfect, but that's okay. I can upload a perfect one later. But basically, we're looking for that if there's a charge, that our atomic symbol looks just like this example. See, there's one thing I'm gonna look for. And so the way you get to these charges, if they're the same, okay, so here's like I have one, did I write it down? Okay, so what is 9 minus 10? 1, awesome. What's 8 minus 10? 2. What's 23 minus 29?
3.
3. So I think this one is actually backwards. So if there are more electrons, the charge is negative. This one is correct. So 20 protons, 18 electrons. That one is 2. It is positive. So that's what we're going to go over tomorrow. So this one, probably going to give y'all like a pass on this one. So if you turn it in, be like thumbs up. But I'll give you a real one. Next week, we'll like do this again next week when we've done ions. So if you turn in your homework and you got some of these wrong, I'm not going to count you off on it. Just know that that doesn't mean that it's perfect. We'll revisit this. Yes.
So there's a quiz, like,
Yeah.
what's that gonna be?
It's going to be on what y'all presented on Monday. I'll tell you more about that. We're like so close. Give me like 5 minutes. And do I have time?
Yeah, well, you have 30 minutes left.
Oh yeah, we're good. So this, like I said, I think I'll probably pass out a blank one of these next week, and we can try this again once we learn more about ions. Okay. Okay. So there was one quiz. This is our last quiz question. Calcium 44 is the second most abundant isotope of calcium. How many neutrons are present in 6.501 times 10 to the 8 atoms of calcium? This is what I was just showing you here with this last example. To solve this problem, first you got to figure out the mass of one atom. So the mass of one atom is either the atomic weight given to you on the periodic table, or if you're given an isotope, it tells you right here. This 44 means that's its atomic weight. Thank you, Brody. And we know how many protons there are from looking at the periodic table. Calcium has 20. And then so we subtract, so 20 plus what equals 44? 24. So we can plug in 24 times the total number of atoms we're given to get 1.56 times 10 to the 20 neutrons. So do you all understand how when given the mass and number of protons, how to solve the number of neutrons? Yes, awesome. We're gonna do like a gizmos lab on Wednesday, where you'll get to like play around with the effects of adding neutrons and the effects of adding electrons and taking them away. If it doesn't make total sense now, you'll get like some hands-on practice on Wednesday. Okay. Whew. Okay. So grades. We haven't done like a whole lot of grades, but I like to plot things, so I just thought I would show you. Not like well, there's a little bit, there's no names, don't worry. Like nobody's names are ever revealed. And basically like we're only like a quarter of the way through. So there's like plenty of time to maintain your grade or bring up your grade. But I think it's helpful to like know where you are so you can know if you need to maybe change any studying habits or not. Okay, so y'all did this in your data Excel lab. You made a graph and put a trend line on it. And so I took what I'm showing here. Can anybody read the x-axis? Assignment average. So you've done 3 labs and 2 homework. So there are 5 assignments. Those things were averaged. And this is the assignment average. It goes from 0 to 100. And what is on the y-axis? Current grade. Okay, cool. So this one doesn't go quite as, it does go all the way to 0, 0 to 125. A couple people have over 100 because I have a couple like 1 extra points here and there. Okay, so what are some things that we notice about this line? What does it do as we go from left to right? Yeah, okay. So the higher your assignment score is, the higher your final grade. How close are the dots to the line? Pretty close. So what does that mean? Is assignment average a good predictor of current score?
Yes.
Yes. Okay. So basically, right now, given that we haven't had any exams and we've only had 2 quizzes, your assignment average is like making up your entire score. So, if you were to have an assignment average of 75, what is your probable current grade? 75-ish, yeah. If you made 100 on your assignments, it's 100. So this, you could like use this equation to kind of like plug in a guess for an assignment score and guess what your final grade would be. Okay, so basically, so people aren't making zeros on their assignments that they turn in. They are making zeros on assignments that they don't turn in. So, and usually, with a couple exceptions, usually when you turn in an assignment, you don't get lower than a 70. So if you turn in all your things, like you're guaranteed to get a C, pretty much. Now that's a hard promise. But turn everything in, you're gonna have a way better grade than not turning anything in. Any questions about that chart? Okay, so I have 3 things to grade in my Canvas. The 3 things that I need to grade are homework 3, lab 4, and homework 4. And so there are 29 people in this class. So what does that mean by how many people haven't turned in homework 3 yet? 8 people haven't turned in homework 3. So like I'm not looking at y'all because I don't know who it is, but like I'm looking at y'all. It's better for everyone. I like to kind of get most of them in. I like to grade all the papers at once because then I can be really fair when I'm grading all of them at once. You should kind of go through and look and see like what the answers are. And when I grade the whole class and then a week later I come back and grade, it's complicated and it makes you want to count points off. I haven't been. If you were 2 weeks late, I counted a point off. But yeah, get them in. It's better for everyone if I can like grade them at the same time. Okay, so yeah, so a couple people still need to turn in homework 3, homework 4, and lab 4. So Tuesday, if you haven't turned those in, like work on those on Tuesday. Yes. Okay, any questions about assignments to turn in? Okay, okay, so my like key point, like if there's a summary to all of this, double check your work. So when you get an answer, like ask yourself, like, does this answer make sense? Is it way too big or way too small? Do I have my units? Is it in the same units that the answer wants them to be in? Check again with your calculator. A lot of people have everything written down beautifully, but their math is just wrong. Google it. The answer might be known. So if it asks you like, what is the atomic mass of cobalt? You can look that up. If it asks you to calculate it, but then look it up. Again, you can Google all the conversions. How many kilometers is 1 mile? You can Google that and check your answer. Show your work and don't forget your units. Any other suggestions that people have for doing well? No.
Get them all.
Okay. Yes, turn in assignments. Is that on my last slide?
One of the things is like, I think you guys hopefully that was helpful to see like, really good ones, but also helpful to see like the average ones, because I feel like sometimes you guys are lacking self-confidence with your submissions. Most of your work is actually pretty good, and sometimes you guys are like, oh, it's not good enough, so I'm just never gonna submit it. And then you get anxiety and you're just not gonna submit it. It's better to submit something, even if you're not fully confident, than not to submit it at all. You don't submit it all on zero, right? It's just the simple math of it, but I know there's some like anxiety there, but try to overcome that.
Yeah, I feel like I can see like inspirational posters that's like the only way to fail is to not try or something like that. I don't know, there's a cheesy one. Yeah, like if you don't try at all, this is one other comment. Thank you for sharing, because I remember one thing. Okay, if only the people that make 100 turn in their work, I'm gonna grade a lot harder. Because I'm like, oh, they get it. There's something about, but like when I see your work, I'm like, okay, 10 people didn't get this. Like, I'm not gonna take. It's like, oh, okay, maybe instead of grading this harshly, maybe I'll take a moment and explain it in class instead of grading it harshly. If everyone gets it right, and then, yeah, it's just better. Better if you turn it in, even if you're not proud of your work. It's better to try. Because then I know what y'all are struggling with. If you don't turn in work that you're struggling with, then I don't know that you're struggling. Does that make sense? Okay. Okay. So I feel like I should have another slide, but I don't. Okay, I'm going to go ahead and stop this. So what we're going to do now